Yeah, I would probably go through the whole class with my mic not turned on. Done it before. Uh, all right. So this week we're dealing with the fundamental principle of counting. We're dealing with permutations and combinations, and the reason we're dealing with this is because next week we're going to get into some simple probability, and then that's it. Week number 7 or week number 18, there is no final exam in this class. This is basically a senior laden class, so I did not expect you guys to take a final exam. So this week and next week, and you're done for the semester, well, for the whole year. The fundamental counting principle, as I was saying before I turned on my mic, if you read the fundamental counting principle, it says let E1 and E2 be two events. The first event, E1, can occur in M1 different ways. After E1 has occurred, E2 can occur in M2 different ways. The number of ways that the two events can occur is M1 times M2. Whew, that's a lot of jumbo words there. Basically what they're saying is if you want to know how many different ways two events or three events or four events can occur, all you have to do is just multiply the number of ways each one can occur. For example, if I had a dice, we know there's 6 outcomes on a dice. And if I have a coin, I know there's 2 different outcomes on that. So if I multiply them together, there are 12 different ways that if I toss a coin and toss a dice that they can come out. And I could list them all out. I could get a 1 and a head on the dice. I'm sorry. I could get a 1 on the dice, a head on the coin, 1 on the dice, a tail on the coin. I could get 2 heads, 3 heads, 4 heads, 5 heads, 6 heads. I could get 1 tail, 2 tail, 3 tails, 4 tails, 5 tail, 6 tail. So if you add all those up, that's 12 different possibilities there could be. But it's very easy to just multiply the total number out. Okay, that is called the fundamental counting principle. Then we'll also talk about permutations this week. The number of permutations of n elements, the number of permutations would be just n times n minus 1 times and all the way down to 1. And we talked about factorials already. A factorial, if I had 6 factorial, that is just 6 times 5 times 4 times 3 times 2 times 1. Now, there are ways that we can order things, and that's why we're going to use factorials. For example, permutations. Permutations are when order matters. For example, if I gave you, let's say there are 10 people in a race, okay? There's 10 people in a race, and there's going to be a first place winner gets $1,000. Second place gets $500, and third place gets $100, and nobody gets anything after that. Well, doesn't it make a difference if you come in first, second, or third? This means order matters. So if I wanted to find out how many different combinations or how many different permutations there would be with 10 people in a race that there are going to be 3 places, then what I would do is I would say 10 permutate 3. Now I could list them all out. I don't want to because then you'd have to come up with 10 different people's names, and then you'd have to start rearranging them, 3 people in a thing. Oh my goodness. No, we have a cool little formula right here that will tell us how many different ways it can happen. So n factorial, so this is your n value, the total number. So that would be 10 factorial all over 10 minus your r value, which your r value is the number of ways you're going to order them. So 10 minus 3 is 7 factorial. So now if I wanted to know how many different ways you could end up first, second, or third place, it would be 10 times 9 times 8, because the 7 factorial would cross off. So what would that be? 720? 720 different possibilities. Okay, now I'm going to show you how to do this with a calculator, okay? Because, why do all this kind of work? So I'm going to write this down, 10 permutate 3. Okay, so I'm going to go into Desmos calculator. Now, if you have a graphics calculator, most graphics calculators do permutations. I'm just going to show you my calculator, or the Desmos calculator, and show you how it does it on the Desmos calculator. Okay, I just have to pull it up. Okay, so let me share this with you. All right, so share application screen, Chrome tab. All right, there we go. All right, so you should be able to see my screen right now. How do you find permutations? Okay, so we have to go down to this little keyboard here. Click that on. Go over to functions, and I believe it's in statistics. And here we have NPR or NCR. Now, we haven't did NCR yet. NCR is combinations. NPR is permutations. Now, before we use this button, we have to put the 10 in. Okay, so you have to put your number in first. So 10, and then hit this button, and then permutate 3. And we end up with, oh, that's not how you do it. Darn it. Maybe I have to put the 10 permutate 3 in there. I haven't used this calculator in a long time. Let's see if I do it this way. Okay, there we go. You have to put your numbers in parentheses behind. Okay, so 10 permutate 3 would give us 720. Now, if you have a graphics calculator, usually you have to put the 10 in first, then hit the NPR, and then the 3. But with the Desmos calculator, you just put in parentheses, and you get your answer. So you can use Desmos calculator tonight when you're doing these types of problems on your assessment, okay? So I'm going to turn that off. So let's get out of there. Get back down to my presentation here. Let's see here. So I want to go back to week 16. I think that's the one. Oh, that's the wrong one. Okay, so you have to go back. All right, week 16. Hard to believe we're in week 16. All right, let's see if that's the right one. No, that's not it either. Oh no, I messed. Where did I put that? All right. Week 16, where are you? Oh, there we go. Got it. All right. So, permutations, you can do it by hand using this formula. Permutation means that order matters, okay? Now, we also talking about combinations. Combinations are when order does not matter, okay? And here's the formula for a combination when order does not matter. Now, again, you can use the Desmos calculator, or, and I would ask you guys to try it by hand just to see if you know how to do it. But here's an example of when order does not matter, or when order does not matter. Okay, so combinations, order doesn't matter. Let's say I want the Pizza Hut. Love Pizza Hut. Okay, and I was going to. They have 10. Let's say they have 10 toppings, and I want to buy a pizza with 3 different toppings, and so I go up to the counter and I ask them, okay, I want ham, green peppers, and onions on my nope, I'm going to go pineapples. I love pineapples on my ham and pineapples. Okay, so I want ham, green peppers, and pineapples. So I went down and I sat at the table waiting for my pizza to come up, and after about 5 minutes, it's like, no, I don't want ham, green peppers, and pineapple. I want pineapple, green peppers, and ham. Okay, are they going to have to change the pizza? And the answer is no, because it doesn't matter if you order ham, green pepper, and pineapple, or pineapple, green pepper, and ham. That is exactly the same thing. You're going to get the exact same pizza. Order does not matter here, okay? So when we do order does not matter, we use this formula. Now, guess what? It looks exactly like the permutation formula, doesn't it? I mean, if you look at this, this is the permutation formula, and then you just have this added on. Well, what does this do? This crosses off all of the overlaps. So that extra r factorial is just going to cross off everything that overlaps. So order doesn't make a difference there. Okay, so in Desmos, you can go to stats and then the NPR, and you just put your values in. Okay, so you can use Desmos tonight on your assessment. All right, let's take a look at this week's practice. Now, when I do problems like this, I usually do, and I'll show you how I do most of these problems. It says, determine the number of ways a computer can randomly generate an integer between 10 and 20, inclusively. That is a composite number. Composite number is a number that is not a prime number. Okay, so this problem, there's not a whole lot to think about here. I just wrote down 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And then I just cross off all the prime numbers, right? Because it said it wants it to be composite. Well, 11 is prime, 13 is prime, 17 is prime, 19 is prime. So I've got 1, 2, 3, 4, 5, 6, 7. There are 7 ways a computer can randomly generate an integer between 10 and 20 that is a composite number. All right. So now the second problem, this is the fundamental counting principle at work. Okay, here it says, at a high school cafeteria, diners can choose 1 vegetable from a choice of 5. Okay, so we have a choice of vegetables, but we have 5 choices for them. 1 meat from a choice of 2 meats, so we're going to choose 1 meat from 2 choices. It could be either chicken or beef, whatever. 1 serving of bread from among 2 breads, so I'm going to choose a bread. I have 2 choices there. And a dessert from 3 different desserts. So now the fundamental count, and then it says how many meal configurations are possible. Well, all I have to do is just multiply them all out. 5 times 2 times 2 times 3, so that's 10, 20, 60, is that right? 60 different meal combinations that you could have. All right, the next problem I'm going to let you guys try. This one, it says, how many 3-digit numbers can be formed if the leading and ending digits cannot be 0? Okay, so how many are there? And I'll show you how I would do it, and I'll see what you guys get for an answer first. All right. Now, this is how I would do a problem like this. It says, how many 3-digit numbers can be formed? Okay, 3-digit number. 1, 2, 3. Okay, so that's a 3-digit number. If the leading and ending digits cannot be, okay, how many choices? So this is really the fundamental counting principle if you think about it. How many choices do I have for the first digit? How many choices do we have? 9. We have 9 different choices, right? It can't be a 0, so we have 9 choices there. Good. How many choices do we have for the second digit? 10. That's exactly right. And then the last digit, just 9, right? Because again, we only have, it cannot be a 0. So I just did 9 times 10 times 9. Is that 810? If my algebra is correct, or my arithmetic is correct. So when I do problems like this, a lot of times I just use the fundamental counting principle to get my answer. Okay? So let's try another one. Here it says a combination lock will open when the right choice of three numbers from 1 to 35 is selected. How many different lock combinations are possible? Again, I am just going to use the fundamental counting principle. It's a 3-digit lock. 1, 2, 3. How many choices do I have for the first spot? How many choices do I have for the second spot? How many choices do I have for the third spot? Well, 1 to 35. Looks like I've got 35 choices for each spot, right? Because you could have a combination that's 1, 1, 1. I mean, it's not a problem. It doesn't say you couldn't. It doesn't say that the numbers can't repeat. Now, if they said the numbers can't repeat, then I would do 35, 34, 33. But it didn't say that. It didn't say that the numbers couldn't repeat. So I'm just using 35 times 35 times 35, which I don't have my calculator here. What is 35 times 35 times 35? What should the correct answer be there? No, nobody has a calculator today? Letter C, 42,875. All right. The next one, it says evaluate 8, permutate 3. Okay, so now, I mean, I could use the formula. Permutation formula is n factorial over n minus r factorial. Okay, the n is always the largest number, so I would do 8 factorial over 8 minus 3 factorial, so that's 5 factorial. And if I multiply this out, it's going to be 8 times 7 times 6, isn't it? Because the 5 factorial, they all just cross off afterwards. So 8 times 7 times 6 is what? 8 times 7 times 6 is letter C. 336. Awesome. Now, we could have went to Desmos, and we could have plugged this in. Did either of you guys go to Desmos and plug it in? And see what you get for an answer? I mean, because you should get the same thing, right? Hopefully. All right. Evaluate using a graphing utility. Okay, so this one, it's telling us that we should use, it should say, using Desmos, or I don't care what one you use. Okay, so what I'd like you guys to do is I'd like you to try and see if you can figure out what 15 permutate 6 is. Okay, using Desmos, hopefully, to see if you can, if you understand how to use the Desmos calculator, because it is going to come in very handy this week on your assessment. Okay, what should my answer be there? Letter B. Now I didn't do it, so Wesley, do you agree with that? That the answer is B. I did not do the problem. Well, 3,603,600. Whew. I don't think I wanted to multiply that one out. Okay. Okay. So did you, Wesley, were you able to plug it into Desmos and get the correct answer? Okay. All right. I just want to make sure that you guys know how to use Desmos to plug it in. All right. Awesome. All right. In this problem, it says 9 weightlifters are competing in a deadlift competition. In how many ways can the weightlifters finish a first, a second, and third? No ties. All right. First thing we have to do is we have to decide, is this a permutation or is this a combination? Okay. Does order matter in this problem? First question you should ask yourself. Yes. So if order matters, we're dealing with permutation. Okay. So I've got permutation. Here I have 9 weightlifters. That's my n value. And I have 3 different ways that they can finish, first, second, and third. So there's my problem. 9 permutate 3. Now, I am not going to use the formula. I'm just going to go right into Desmos. I'm going to plug it in, and I'm going to get my answer. Okay, and I'm going to do that because I have Desmos up. So I'm going to, well, somebody's already got the answer. Let me put 9 in here. Okay, 504. 504 is correct, right? So when you have a problem like this, first thing you have to do is you have to ask yourself, does order matter or does order not matter? And then you just pick permutation or combination and plug it into Desmos. That's pretty easy. All right, last question, I believe, on our assessment this week, or on our practice this week. It says there are 13 patients in Dr. Ziegler's waiting room. Dr. Ziegler can see 5 patients before lunch. In how many different orders can Dr. Ziegler see the 5 patients before lunch? Now, this one, I'm doing fundamental counting principle. It's like, okay, 1, 2, 3, 4, 5. He can see 5 different patients. How many ways can he see the first patient? Or how many different patients are there? 13. Okay. Now that patient is being seen. How many different ways can he choose the second patient? 12, right. And it's just going to go 13 times 12 times 11 times 10 times 9. And if I did this, now, does order matter here or does order not matter in this problem? What do you think? You think order matters? No. So order doesn't matter. So I could have done this. I could have did 13 combination 5, right? That I could have done that. Or I could have just did 13 times 12 times 11 times 10 times 9, and that, to me, that was a little bit easier. 13 times 12 times 11 times 10 times 9. And I come up with 154,440, if my simplistic calculator works. Letter D. All right. I think you guys are going to have an easy time with this week's assessment. It's not too bad at all. That is it for today. Any questions? I will say, it's beautiful outside today. It's supposed to rain almost all day tomorrow. Get outside and enjoy the weather today. Do your work tomorrow. I'm always looking at the forecast. Whatever day is going to be nice, I want to be outside. Whatever day is raining, I can do my schoolwork then. All right, you guys have a great day. And we only have one more session to go. Bye.